Michael, thank you for joining us. It is a pleasure to meet you. I do know Frank for a few months because he's a premium member of the community, and he explained everything you do with C Machine Robotics, which you found and you also manage as a CEO. But what I liked about doing some research is that you are not like some wizard kid from university who starts, hey, autonomous shipping, that's nice, let's go there. You have been in the field for over 16 years. And you started around the same time that I left the Maritime Academy, and that was 94. You started 96, right. From your mechanical engineering background. Tell us a little bit your journey before C Machine Robotics. What were your ambitions? What would you do? What was life then?
Yeah, well, thank you very much. And thanks to the Lisa community for having me. Sorry about that. I'm in my bright conference room here and the light keeps going in and out. So bear with the computer screen doing that. But yeah, so my journey, as you mentioned, gosh, even before Maritime Academy. So I graduated with a degree in marine engineering, and then also got the U.S. Coast Guard license to sail as well. But prior to that, I'm a Texan. Grew up half of my life grew up in the city, and half of the life grew up on a farm. We were a catfish farm. And we spent also a lot of our time on the coast, on the beautiful Gulf of Mexico, a lot of fishing. And I really became enamored with the sea there. I actually went to, my goal was, I'm a huge conservationist, so my goal was to become a marine biologist and, save the planet. And the school I went to, Texas A&M University, which has a maritime academy, has marine biology, but also, as I mentioned, the license program. I quickly realized that there was a lot more that I could do in life, in being able to make the salary of a marine engineer as compared to a marine biologist, especially back then. And I thought, well, I could put my ideals to work with the money I could make in marine engineering. And so anyway, I became a marine engineer. During the course of school, I sailed quite a bit as a cadet. I did a year of sea time. And then in my last year, I started interning as a young engineer at a shipyard that was just down the road, and happened to be one of the cycles of building for the offshore drilling industry, and got put feet first right into a rebuild of an old diving platform, semi-submersible diving platform, into an offshore drilling rig. It was going to be DP3, and it went off of Brazil. And so graduated, went right to work into the shipyard, but unfortunately, the shipyard business, it's cyclical, and that yard eventually went bust. And then from there, I went full on into offshore drilling. Went to work for a company called Diamond Offshore, and was a project engineer, again, servicing rigs around the world, from Verlome to the North Sea, to Australia, to anywhere there's a major area where the rigs are working and where they're bringing them into shipyards. Made my way through a few companies in that space. I lived down in Singapore with a lot of those projects, had apartments down there, and working in Indonesia, and seeing the environment there, and seeing that it wasn't like what I thought it was as a kid when I would read the nature magazines. Kind of that stuff started to reemerge, those thoughts about conservation. So I actually jumped out of the marine industry, I think in 2002, 2003, and started a company that was totally focused on the environment and conservation, and brought it into the United States. And I said I was going to do this, selling environmental products until you could find them on everyday shelves. And that actually happened, and sold the company in 2008, and then went back to work, was into the marine industry, again, shipyards. Then I found myself as a consultant to BP, managing some sea lifts up to the Arctic, where they were doing, drilling on the north side of Alaska, Prudhoe Bay, um, really overseeing the marine transits of equipment up there, and then was attracted to become a vice president at the Crowley Corporation in the U.S. There was a very exciting opportunity, being major role in their global projects group. So again, taking on some of the extreme challenge, large challenges. That's what I'm attracted to, is doing something new and different all the time, and significant. So significant projects in Chivo, Siberia, down to untouched areas, coasts of Panama, where it really is very secluded. And then we also owned a major, uh, one of the world's major salvage companies. We own Titan Salvage. And with my role over the projects group, I was also able to support our salvage efforts, in helping them bring together the programs, projects. And we had a lot of interesting ones, a lot of wreck removals. Probably the most significant one was the Costa Concordia cruise ship in 2011, when Captain Scatino drove her onto the rocks there off Giglio Island. Very tragic, and but we went into it with what we do. Very competitive industry. Smith Salvage had the early part of the project, and we went in there and competed for the wreck removal. Put together a very, I think, advanced engineering commercial proposal, and is able to win that $1.3 billion project. But it was really during that time of managing and living on that island of Giglio, there off Italy, and looking at that wreck every day, where my thoughts about really needing to move our space into the 21st century. We have beautiful vessels. We have a beautiful market, obviously a beautiful domain, but a lot of our operations are still very much like they were in the 20th century. We rely on 20th century methods, and a lot of our technology came from the 20th century. And I look at that wreck, and I saw that one person could make a decision to steer that $680 million ship onto the rocks and create that type of accident. And I recognize, we have major accidents in our space, incidents, accidents every day. I mean, it's a fact. You go onto Wikipedia and type in shipwreck, it's every day. And that, along with needing to improve our productivity, really just, move our space into the 21st century to take advantage of new technologies to boost our relevance, is why I then jumped from there and started Sea Machines in 2015.
So if the Concordia didn't happen, there was no Sea Machine Robotics.
Good question. The thoughts were actually starting before that. So, we were, I was over pulling together, I was responsible for pulling together a number of the oil response assets for Shell in their endeavor to work in the Chukchi and Beaufort Seas. And there's a lot there where I recognized that we had, very advanced skimming equipment. We are able to, at control systems where you can turn it on and it does its job, but then we're installing it onto vessels that needed a lot of hand holding, and we learned quickly in those very remote areas that the fact needing to get people onto the vessels, people off of vessels, was the weak link in being able to be ready to address a spill up there in the Arctic. And that was kind of the first, that along with, just many years of thinking about wanting to, boost technology in our space. Probably would have happened, but the Costa Concordia definitely catalyzed it, or made it go a little faster.
So going into then the new technology and the things that you are hoping to achieve, what is Sea Machine Robotics actually doing now, but what is your vision for the future? What would you really like to achieve? Is it also this green idea of making it more sustainable, or also reduce accidents and make it more preserve the assets that we have? So, what is your vision of the company, and what do your company actually do for the people who don't know that yet?
Right. So the our overall goal is to build value for our customers and the industry as a whole. We want the our customers to be able to achieve more with less effort, because that's kind of the way we as a most of our global society is we're always trying to expand and do more, inflate. And I think the only way, one of the main ways that we can do that is through leveraging advanced technology. And again, our goal is for the industry to find value from these new technologies. And what we have today, it's autonomy. So we launched our first products 2 years ago. We launched the SM200, which is that's just a direct teleop wireless remote helm system that gives you basically it's a joystick, belt pack joystick, gives you a range of about 1 to 1.5 kilometers. We have customers that get value from that, for how long? How long has our industry been attached to the wheelhouse? And it's probably ever since there's been a wheelhouse. And now we have customers that recognize that if they can control their vessel from outside the wheelhouse, just be able to step out, get a better viewpoint on maybe the work they're doing. Maybe it's a tug that's doing something with another vessel, pushing barges, actually controlling it from the load, meaning like you're pushing barges, you want to control the vessel from the load, or control the vessel from another vessel. So it's that this new product, it opens up opportunities and capabilities for our industry. And what's exciting about it, to me personally, is when a customer operator takes our technology and uses it in a way that we never would have guessed, and finds value in a way that we never would have guessed, So we provided that platform. But our other product is our flagship product. That's the SM300. So that's our autonomous command and control system. So it shifts effort from the manual human to the computer system. And what it does is it takes on really the routine in often ways. Our industry has a lot of the transits projects. The work we take on involves normally long duration, and much of it, over 95% of it, is very routine work. And we recognize that human mind, human in the whole is that's we're not really good at routine work and long duration. And that's where you see that a number of industries, not just ours, but automobile, manufacturing, in those routine operations, you see that the accidents and incidents, like 80% of them are driven by human error, and it's usually because we get distracted, we get fatigued. We change out people, when you're standing a watch and you do 4 hours and then another person comes in, another person comes in, there's those breaks in it. So you take that routine and you shift it to an autonomy system that's, that system that's always on watch. And it's less fallible in many ways there. Believe me, there's strengths that humans have, of course, and that a lot of that is around the edge cases, those unique things that happen that the human knows how to respond to much better than the computers today, than the computers will be 20 years from now, and the algorithms as well. So our autonomy system is being used today in first in a lot of the task-based vessels, and in industries that kind of have a managed domain. And say one specifically, major industry that is turned to this is marine surveying, data collection. And our work that we're doing in the Netherlands with Deep BV, other survey companies in Australia and in the United States, they have programs where they need to go run collect data over 20 by 30 kilometer area. Obviously, sometimes it's more than that. And they run lines back and forth, back and forth. Early on in doing the research for this company and interviewing companies that are involved in that, I would hear about error rates, where they have like a 30% error rate, that having to go back and recollect data. And often it was described as, that we just, in our manual operations, we lost track of the line, just things that a computer system, that a well-built autonomy system will not do. So our autonomy system, it sits on board the craft. It's an edge computing system, meaning that it doesn't need connectivity to a cloud or any other data sources for it to make its decisions. It has a built-in electronic navigational charts, and it brings in, it localizes by GNSS, and we have a collision avoidance in it that takes data, perception data from both off-the-shelf radar systems, be it Furuno, Raymarine, soon Garmin, and then also AIS. And so those perception systems are good, but they don't see everything. And so that's why today our systems are being used in managed domains. But our path is over the horizon. Our path is dock to dock autonomy. And so we have other technologies that we're building, such as computer vision as a new form of sensing, to be like the eyes of a mariner, that will empower our systems to be able to do that.
Well, thank you, and I think you're doing a very good job. I just read recently your cooperation strategy with Dama Shipyards. Congratulations with that. Very cool to see.
Thank you.
I would like to open up the floor to anyone to ask anything to Michael. You can do it three ways. You can either put something in the chat, or raise your hand, or unmute yourself. And to let you think a little bit, I have two questions from Martin, who said he would leave early. So I will pass them on behalf of him, Michael. One is, who are your customers?
Yeah, good question. So today, as I said, it's a number of them from the workboat sectors, survey companies. We mentioned Deep BV. There's a company here, other survey companies here in the United States. We also, when you talk about advanced technology on water, we really are, we're commercial. We're from the commercial industry, but our first customer that was waiting for our products was the defense space. So we've been putting systems into patrol vessels, surveillance vessels, again, being able to use technology to leverage its capability, leverage new capabilities. But back to the commercial space, we are working with early adopters, innovators, and early adopters from many other industries, such as crew transfer vessels. So the back and forth, very routine operation of sending crew to the wind farms, or oil and gas, but a lot of the early adopters seem to be in the wind farm space. What the space is learning is that it's a routine operation, but you are driving, piloting a vessel through a pinball course of multiple turbines, and while those turbines don't move, there's still obstacles that the distraction and fatigue of humans can we've seen accidents from that. And so we'll be announcing some work that we're doing with operators in that space. It's been published, our work that we've been doing with AP Moller Maersk, And that's really in advancing our computer vision technology. They were looking for a new type of situational awareness for their vessels. They they've been living for a while with you know, conventional marine operational risk of incidents, but also just mainly risk to their schedule, you know, and a lot of that comes from operating in crowded waters, you know, kind of initiated from operating in crowded waters like South China Sea or East Asia. And they want to be able to perceive their domain a lot better and quicker so that they can react better instead of just trying to, you know, like today when they get in those crowded waters, they tend to just either divert or slow down, and that impacts their planning and schedule because what their overall goal is predictability. You know, the more predictable they can be in their operations, the better they can plan, the better they can move money to the bottom line. So we've been working with Maersk, and we have some other shippers, which is kind of like one of my dreams is moving this technology into the shipping space and empowering the transit of cargo. We have some other shippers that we'll be announcing later this year that are starting to install autonomy systems onto their vessels.
The second question he had is, why did you end up in Boston, coming from the Lone Star State?
Yeah, it's a real good question. I love Texas, of course, but as I mentioned, I had started a company before, sold a company before, but this is the first company that I was going to have to take outside money. I knew it was going to take quite a bit of capital to build what we're trying to build, and that need for capital is really, you know, held our space back in pushing this technology so far. You look at the large players in this space, a lot of them Northern European, the OEMs. They've been they look for capital from the EU, from governments to help empower their innovation. I knew that I was going to have to look at venture capital here in the U.S. And you know, they, you know, as global as the world we are, or we try to think that we are, they really do focus on areas, you know, and they color you based on where you are. So trying to build a venture-backed company in Texas, it's a lot lower chance of being able to raise money. But if you're in Boston or if you're in Silicon Valley, you know, it's something to it, you know, that you've got a piece of what's necessary to raise money. But another big part is the talent that we need to do here. So you look across our industry and much of the world of automation, a lot of it is one-to-one, one feedback, one signal feedback, and responding to that. And that's what most of our automation is. When you get to autonomy, it's the balancing, you know, these autonomous systems, it's the balancing and interacting of multiple data feeds, multiple signals at one time to make decisions, prioritize decisions. And that's really the difference between late 20th century automation and moving into the 21st century autonomy. And here in the Boston area is where a lot of the talent is coming out of. You know, we have it's the robotics hub of the US, but also we have, 51 universities here, MIT, Northeastern, that specialize in these areas, and we bring them right into our company.
The Boston Robotics is also based in Boston, I assume.
Uh, yeah,
Those
Boston.
guys with these nice movies where robots do all flip flaps and all the kind of
Absolutely.
stuff. And
Absolutely. So that talent, you know, that it takes to make those, you know, the processors that work quickly with the hydraulics. I mean, that we were able to pull from that kind of talent as well. But the other piece of it too is the proximity to Northern Europe. You know, I know as somebody working as an American working in the marine and maritime sector, that you know, Northern Europe is much more significant to the global marine and maritime sector than the U.S. is. You know, I mean, we move like 1% of our domestic cargo by water, and I think Europe on a whole still moves like something like 40%. And it just talk to a regular American about marine and maritime, and it doesn't really resonate, whereas Northern Europe, it is definitely respected, appreciated. A lot of the owners are there. And so being closer is important to us. Early on, we opened up our European office in Hamburg as well, our first one. And then Frank joined us closely after that from, bringing a presence in the Netherlands.
All right. Who would like to ask a question? Danny.
Yeah, I would like to ask a question. Considering that you also have anti-collision software within the system, do you have any news about near misses or somewhere where your system actually made a difference between a collision and a safe passage?
Yeah, that's a good question. I think from a system that's being used by a customer, I don't have news about that. I look forward to that. But like I said, a lot of our customers are, it's a big enough step for them to bring autonomy in, where they have a system that is controlling throttle, gear, along with steering to maintain a course or collaborate with another vessel, to where we have a lot of them say that, that's great, you have a collision avoidance, but we're not going to actually use that yet. We get enough value from the path planning and navigation that your system does. We run a test fleet of 3 vessels, and we test the heck out of it. And so we definitely in iterating, and we get our own number of near misses, or what we see would have been a near miss if we hadn't changed course as we've developed the technology. I think Frank might know better than me. I think just 22 of our systems have been deployed so far across the world. Yeah. By the end of this year, we should have, over 120 systems that have been booked. There's a time between booking and deployment. So we should be over, 60 systems, 50 to 60 systems deployed. I look forward to, being able to serve customers more that are using the collision avoidance, obstacle avoidance technology more.
Michael, this is Vino. So I'm here in Miami, Florida. So my question is, how involved is C Robotics in the underwater hull maintenance? I know you have an office here in Stewart, Florida, right?
No, that's a different company.
Okay.
Yeah, so you're referring to C Robotics? Yeah, we're C Machine. So C Robotics, yeah, they're older than us. They've been around a while. They definitely focus on survey and also smaller packaged, I don't know what to call them, plastic survey vessels. Also, as you mentioned, maybe hull cleaning. We're really, we're about empowering, commercial marine and maritime vessels with control system technology.
Yeah, okay, that's great, because I'm a student of mass maritime as well, probably the oldest one in the class. So doing my master's. So what I've been working on also is, as you've seen recently, there's so many ships that have lost containers at sea, right? Those larger vessels. So I was thinking, how we could, because probably what I think, I've sailed before also as a chief mate with on big container ships like APL and CSAV and so on. So what could probably be is, what I think is the GM. The calculated GM and the actual GM could have been different during that occasion when the ships lost containers, or at least a couple of minutes before. So also using the clinometer, how we are going to give not only the captain the visibility of what's going to happen, a predictive analysis of what's going to happen, also probably the fleet manager ashore, like he should have information on what's happening to the ship at that time, you see. So not only the master will make unanimous decision on to alter course, which could impact his job, but at least it's a joint effort between the shore and the sea.
Yeah, so I like where you're going with that. You know, I don't know all the specifics, and I'm not going to read into some of those, you know, incidents. Also, I'm an engineer, not a not a deckhand. Don't work the decks, but where I think you're going with it for sure is data and data streams and being able to measure data streams from sensors, and so that to help us make better decisions, or actually better is to provide warnings or direct alterations to course based on sensed, based on dynamics that are being sensed. We have that within our system today for the smaller craft, where an operator can set their limits of slamming, pitch accelerations, and even roll. Primarily, slamming and pitch accelerations is used for, you know, where the system automatically throttles down, slows the craft if it's seeing limits over, or dynamics over those limits, and then once it calms down, you know, over a little bit of time, it'll speed back up. We also have an anti-roll algorithm that we'll be deploying soon as well. So getting feedback and bringing that data into an intelligent system, into a brain on a vessel, will enable our industry to do more with less incidents, and I could see, you know, these incidents where they lose containers as well.
Thank you.
Thank you, Vino. Eugen.
Question from basically just out of curiosity. If you just discussed or explained a bit about the anti-collision kind of solutions, but if you really want to build a solution for that, I think you need to get information from all the different moving objects around you. Most common thing that comes to mind to me is AIS, but it would be nice if you have like 35,000 of these systems installed on each and every marine vessel, right? Because then you can really make it make all communicate together. But at this time, it's just a standalone system. But how do you take care of all the external factors in that case?
Right. So today, as you say, there will be a time in the future where we have a full autonomous network, very much like the airliner space today. Anything operating over 10,000 feet is emitting a signal through a beacon, to where air traffic control is much more about reading those beacons than actually, you know, sending out a radar signal and seeing where the aircraft is. And that's where we will get to eventually. But now, between then and now, there's a big part on vessel traffic. There's a big part of sensing that through computer vision, AIS. It's a fusion of those sensors, as well as radar, ARPA from radar.
Yeah. Because if you're in a crowded area, let's say the North Sea, the Canal, Singapore, right, and Maersk is slowing down due to whatever reason they think it comes up, but you don't have control of that other reason that comes up, and then you may have slowed down basically for nothing, because all of a sudden this object that you're approaching is moving away. And that's something that is not predicted in your AIS system.
Correct. And you know, mariners today have to make decisions on their experience and what they think the vessel is going to do, or direct communication, you know, hearing from that vessel. So we vessels will communicate with each other and send that information in the future, where it is a much more of a choreographed.
And who will then manage, control those beacons and provide instructions to the different vessels? I mean, will it be port authorities or national authorities, international organization?
Yeah, it's a good question. I don't have an answer for you. It's where it's going, and it's gonna, it's going to move into, like, I think gonna happen is you're going to get to a space where there's a percentage of the industry that is using this new technology, and it starts pushing upon, the authorities, regulators to make those kind of changes. Kind of how many of the transitions happen in industries, where you get up to a percentage, and then it starts to feel kind of messy, and then the authorities at some level come together to try to bring more organization around it. And so I do see that happening at some time. I'm not going to tell you exactly when. I don't know exactly when that's going to happen. What we're doing is we're empowering, we're bringing the technology, and we're very, open about where it is today. I mean, we're not telling our customers to go operate our systems in crowded harbors. We are very open that this is for offshore or coastal environments.
Yeah.
If you're using, dynamic sensing and collision avoidance.
Okay.
I have a question on the collision avoidance. You see, this system may work well in the U.S. coast and European coast, but if you have transited through the Vietnamese or Chinese coast, I mean, that's like a kamikaze. You have to go on manual. You have to keep altering course. Nobody follows Rule 8 or collision regulations. It doesn't exist there. So how can and then in the night, as you can see, it's just full of lights and fishing boat, right? Usually the junior officer gets very panicked, and sometimes mistakes happen. I know many of those ships have hit fishing boats before, but nothing was reported because those ships were not, those fishing boats were not even registered. In those countries, on the coast, there's no value for life, right? So, but in case something happens, especially now the Chinese are watching whatever is going on, they could arrest the ship. If you're going to go in full autonomous mode and something happens, don't you think it's a little bit of a risk?
Definitely different levels of complexity in operating domains. Same thing you find in other sectors that are pursuing advanced technology. I mean, our first autonomous vehicles were probably the trains that went around an airport. They're on the same track. They just go around and around, and now you have companies like, Volvo or Tesla that are working on autonomy, but it's really for the highway, direct highway. But nobody right now can see that autonomy and say, this is going to be great in Jakarta, rush hour, or New York City. I mean, it's the technology's not ready for that, and it might not be even necessary for that for quite a while. So, but our space, there is a lot of that highway driving. We have the long duration open transits, like I said, these very routine tasks, and there's value there to shift that effort to a computer system. As the technology matures, as the space starts using it, as we mature together, it'll start, moving towards those more complex situations. But there, as I said, I think for a long time, there's value in having humans on the loop, involved in that operation somewhere. Edge cases happen. We as we said, airliners have done a good job. Airbus and Boeing have done a good job of their control systems where they can be called autonomous in many ways. Many of the Airbus operators and European airlines, will err toward doing auto landing over manual landing. But still, there's edge cases. I mean, and the humans address those. A lot of them you don't hear about because the pilots in the cockpit manage it and take care of it. Some of them you do, like what was it, Captain Sullenberger that landed the aircraft in the Hudson River after they took geese into the engines. I mean, how can you build an algorithm to safely predict and manage that edge case to land into the Hudson River? I mean, your algorithm most likely would have said, you got to get to the closest airport as soon as possible. And what would have happened, And so having humans in the loop, on the loop is important. And our systems definitely have that today and will for a while.
Matthews, you had a question as well.
Yes, thank you. I'm enjoying this. Thank you very much for your time. I have a question for you. I hear you saying a lot about human in the loop, and I'm curious if you could define your level of autonomy. What does that mean when you say the word autonomy?
Okay, yeah. So there's a number. Look, I mean, as a space, we have a number of different scales. The U.S. Navy has their autonomy scale. I think the one that we kind of been leaning toward is the Lloyd's Register scale, which takes it from 0 to 6, 6 being fully autonomous, no human involvement whatsoever, doesn't even need to scream for help. That's a long way into the future. I mean, that's science fiction. It's exciting when we get there, but we're a long way from that. So today, our system is in between level 3 and level 4. You're asking me details I don't specifically remember, but it's a graduation of how much human interaction is in there. For example, level 3 would be more of you have cameras, and the system is controlling the navigation of your vessel, but it's not doing any type of collision detection. And the operator, through those camera systems, or maybe it's on board, is making all decisions on altering course due to detections. Level 4 brings in collision detection and has more authority to make decisions, will change course without having to ask permission.
Okay, and sorry, just a follow-up question. Is anyone using your system in an unmanned mode at this point?
Yeah, so I mean, we've operators that have used it for oil spill response. I mean, because that's a, dirty industry where there's a lot of hazards to humans just by exposure. Again, very routine as well. We have another customer coming up later this year that manages a number of oil response assets. The other thing about it too is, when oil response is one of these things where you never know when it's going to happen, and you have to keep crews trained, and these crews are always, training is, you're always fighting against them not being fully trained. If you could just turn it over to a system that you turn on, and it'll just run those lines in a pattern, or do collaborative autonomy, dual towing of skimmer boom, as we've done, there's a huge amount of value there. Also in the patrol and security, as I said, defense, they're using it in an unmanned way. And then in the survey industries, Deep VV, I think we just Frank did a great webinar. Was that last week, Frank? Talking about their transition to remote command of their vessels.
Before we give the floor to the others, there are still some raised hands. Michael, we're approaching the 45 minutes. Is it okay for you to go along a little bit longer?
Sure, I can go till 10. I can go till the hour.
Perfect. Then Thornton, the floor is yours.
Oh, thank you. I've been kind of very interested in this for a while, I suppose. Got a background in dynamic positioning myself, and as a ship captain now. Really kind of wondering on the front end where there might be new opportunities to get involved as this grows. rather than waiting around for it to show up at my workplace.
Yeah, well, look, we see at specifically at your workplace, as you mentioned, we see the interest in the technology being driven into companies by both the top end, like a CEO saying, we really as a company need to leverage new technologies, stay ahead of our competition. I've learned about autonomy, let's see what we can do with it. But we also have companies where it's coming from other parts, and bringing that message up to the executive level, and delivering, case studies on how their operations can be, more productive, more predictable, or safer based on leveraging new technologies. Right now, there's a number of parts of our industry that are struggling. Oil and gas being down, other sectors that are struggling as well. But what I've seen in the past is it's often during these down cycles where there are new technologies that tend to emerge, because the opposite, when you're at the peak and everybody's blowing and going, is really not a lot of interest in being distracted by new technologies at the time, because you're just trying to make as much money as you can. So I think that there's, while a lot of maybe initial responses will be, it's not the time to invest, I think it's a good time to be, looking for ways to be more competitive, again, do more with less, and encourage you to learn as much about us or competitors. And I that's the other thing, is I look forward to more competition coming up in this space. I envision over the next 3 to 5 years we will be seeing more, especially as our industry continues to see the benefits that other industries are getting from the technology, namely terrestrial, vehicles, and the more that they're leveraging computer vision, autonomous systems to, again, make their fleets more productive, more predictable, and safer.
Great, thank you. Dick, you have a question.
Yes, hello, Michael. My name is Dick Stoppelenburg. I'm Managing Director of Eltec Electrotechnology. We are working together with Frank here in the Netherlands in the development of a autonomous guard vessel. But my question was about your strategic alliance with Damen Shipyards. What do you expect of that alliance?
Oh, I expect a lot. Thank you, Dick, for the question. It's exciting for us. I mean, Damen is, as you know, is I want to call him the leader in the space. The significant in what they've done over the decades to create a unique, way of operating, a unique business plan in moving our space forward with new ways of building, new ways of going to market, new ways of serving the world, and they've been very successful. Yards around the world, customers turn to them as kind of a, you can either go and build a custom vessel the traditional way, working with naval architects, and there's great things about that. Or you can go to Damen, and they have a solution already made for you, and most likely it'll do it for you, and you can get that vessel in 2 months, compared to 2 years. What we are going to do is we're proving our tech, validating it with their various models, and then they'll be taking it to market as an option for their customers. So we started talking to Damen, I'll tell you, 6 years ago. So it's been a process. They've been, they're a smart innovator. You know, they're first in some things, but they when they make a clear decision, they've thought through it in many ways, and they have a value proposition behind it, and they see that this is the way of the future for their space. So after testing many different, being involved in many different autonomy programs there locally, they've settled on working with C Machines, and we're very happy with that. I owe a lot of that to Frank and what he's done there to communicate, our message to them, just to inform them about our technology. And so, as I said, what you will see then is proposals from Damen in going to their customers where there's an option of bringing in C Machines autonomy system, or C Machines remote helm system, or next year a computer vision sensing system.
Do you think that you can lead your own strategy into the future while you're working with such a big company?
I think so. I think it's important for us in our space to leverage the significant brands like Damen. I mean, we are a high-tech startup in a space that normally turns to very large companies for their propulsion systems, be it Rolls-Royce or Wärtsilä, or their bridge systems, be it JRC or Furuno Alphatron. We need to. There's a part here where we're working to scale, where we need to align ourselves with the significant players in the space. But still, when you say, I mean, our space is still very fragmented. So when we say that Damen is a very significant brand, I mean, still their percentage of the overall industry is small. And that's because it's not like the automotive space where there's 30 car companies, and that's it. We have hundreds to thousands of builders and even many more operators, and there's opportunity there throughout the space.
Danny, bring it home before we wrap it up. You had a question as well.
Yeah, I did. I was wondering whether with the autonomous system, there's also ways to integrate fuel efficiency, and that's something you're looking at, especially with the whole green approach you seem to be wanting to take from the start. Is there anything along the lines of speed control, wave integration, things like that, to see whether you can actually get companies to save on fuel and help out the environment with your product?
So you're absolutely right. So this is where it's going in the next year. I mean, so I feel that we came to market pretty quickly with our product, and really it's building the control, low-level control, autonomous control, validating, hardening that, making sure that it does what you want it to do over and over. Then it's building building these interfaces to all the different types of equipment, and we're still doing that too. The APIs to talk to different types of propulsion, steering, and there's still some we are working on. But now, as we've gotten that product out there and it's working, the next phase of it is really leveraging more of the data and doing the analytics behind it and using that data and many different data streams for specific purposes. As you said, fuel efficiency. I mean, there's customers we're working with now that are interested in depth, because the areas that they operate in, the charts haven't been updated for 40 years, and bringing that data in. I mean, and being able to collate it and organize it and bring value for them. But the difference with an autonomy system and what we're doing compared to, there's others out there, as you see, other startups that are, or smaller companies that are working in new types of data streams from vessels and doing the analytics of it. But the difference I see with us is in those companies, you still you receive a report, and there needs to be a human then that interprets that and then takes it to the control of the vessel. With the autonomy system, as you implied, you're taking that data, doing the analytics of it, and you bring it directly down to what happens with the propellers.
Yeah, that was exactly my question. Yeah.
That connectivity and taking the human interpreter out of the loop is really important to building our value in our space. Because you look at, we have a lot of human touch points in our space. And I would think, landing a Airbus A380 at Schiphol compared to bringing a container ship into the port of Rotterdam, I think there's a lot more human touch points in the ship coming into Rotterdam. And that, again, it's the way we've done things. And it's the way we did things through the 20th century. And now we just need to connect those, take people out of the loop, builds our efficiency and effectiveness.
Thank you.
Thank you.
Thank you indeed, Michael, for all the remarks and answers, and also being supportive of the Lisa community. I really like that you are a premium member as well, and also believe in this way of connecting people, sharing knowledge and information, and exchange experiences, and help each other to succeed. We definitely think this is also a way to do business and to drive cooperation in the 21st century. So thank you for supporting us. Next week, we have an Ask Me Anything session with Michiel Het Hoen, founder of MSA Service, their electrotechnical automation company. So looking forward to that one as well. For now, thank you so much, and hope to see you soon.
Great, Jan. Thank you very much. And thank you for this opportunity. And I enjoyed interacting with everybody on the platform. Thank you very much.
Perfect.
Thank you, Michael.
Thank you.
Thank you,
Cheers.
everyone.
Bye.
Cheers.